So, one thing, take example, this is my router over here, right? And this router has a one interface 0/0, and this router has another interface 0/1. At the same time, we have a 0/2 as well, right? So on each interface, we have our own IP address. So for example, this guy's IP address is 101.1. This guy's IP address will be 2.2.2.2.2.1. This guy's IP address will be 3.3.3.1. Of course, right? Each interface gonna represent a separate broadcast domain, right? This interface have a separate broadcast domain. This interface have a separate broadcast domain. This interface have a separate broadcast domain. So each interface has a separate broadcast domain. If I talk about the routing table of the router right now, so if you see the routing table of R1, it looks like we have a 1.0.0.0.0, which is associated with the 0/0. We have a 2.0.0.0, which is associated with the 0/1. And we have a 3. Guys, please pay attention. We have a 3.0.0, which is associated with the 0/2. Now understand what happened if the router will receive any packet where we have a source will be x.x.x.x and destination will be, take example, we have a 3.3.3.1. So normally what happened when the packet will be received on the router 10/0 interface, right? When the packet will be received on the router 10/0 interface, this is the normal packet we have. That packet has this source and this destination, right? What happened? What router will do that? Router will do the lots of things. Router will perform the layer 2, then it will perform the layer 3, right? So in the layer 2, what happened? They will do the MAC lookup, and they will do the checksum. They will do the ether type. Okay. In the layer 3, what happened? Again, they will look up for the destination information. Do we have a destination IP in my routing table or not? Then it will look for the checksum field. Then it will look for the TTL field, right? And based on that, what he will do that it will switch the packet. Listen to my words. It will switch the packet. Switch the packet. Switch the packet from one interface to the another interface. So according to the routing table, if there any packet for the 3.3.3.1, I need to switch the packet on which interface? 0/2. So router 1 will forward the packet to the 0/2. Now understand this concept. I just use the word switch the packet. The meaning of switching, right? Either you can say the switch or you can say the switching. The meaning of switching means what? Placing the packet from one interface to the another interface. The meaning of switching means what? Placing the packet from one interface to another interface, right? That's the meaning of switching. Now, you tell me, guys, one thing, you just tell me, is it a MAC packet or IP packet? You tell me, is it a MAC packet or IP packet? Anyone? Is it a MAC packet or IP packet? This packet that you can see right now, is it a MAC or IP?
IP?
IP packet, right? So the packet that we are switching right now, it's an IP packet. That's why this mechanism is called as a IP switching mechanism. Now, hope you understand the meaning of IP switching. The meaning of IP switching is what? Placing the packet from one interface to the another interface. That's called as a switching. That's called as a IP switching because we are placing the IP packet. If I talk about the layer 2 perspective, right? If I talk about the layer 2 perspective, in the layer 2, what happened? Take example in the case of switch as well. Understand the concept. On a switch, what happened? We have a 0/0, we have a 0/1, and we have a 0/2. On a switching, what happened? We have a MAC table. On a 0/0, we have a MAC A. On the 0/1, I'm so sorry, MAC B, and 0/2, we have a MAC C. So if I will receive a frame where we have a MAC A and MAC C, the source and destination, then what happened? I will receive the frame on this particular interface. I will look for the MAC table, destination MAC, and it's saying that 0/2. I will place the packet on the 0/2 interface. That's called as a what? MAC switching, or we can call as a frame switching, right? But right now, this is the packet that we have an IP packet. That's why it's called as an IP switching mechanism. IP switching means what? Placing the IP packet from one interface to another interface. So we will receive the packet on this interface, and I just place the guys, please. I just placed the packet on the 0/2 interface. This mechanism is called as a IP switching. Now, in networking, if I talk about Cisco perspective, we have a three types of switching mechanism. The first type of switching mechanism is known as a process switching. Guys, please focus on the name, right? Process switching. If I'm just gonna split this word, right? If I'm just gonna split this word, okay, so I will call as a process plus switching. What do you understand from this thing? Easy. So in this process switching mechanism, still my packet is being switched from one interface to the another interface. That's the meaning of switching, right? Still my packet is being switched. Guys, please pay attention. If you understand this part, you will have a clear understanding of the MPLS. I'm telling you, most of the person who is working in the production network, they know how to configure the MPLS. They know how to troubleshoot the MPLS. They have no idea what is the need of MPLS. Okay. Still my packet is being switched from one interface to the another interface. From one interface to another interface. But here the word, it's saying that what? Here the word is saying the process. Here the word is saying the process. Process means what? The process means your router is taking the huge number of CPU to process the packet. Your router is taking the huge number of CPU cycle to process this packet. So in the process switching, what happened? In a process switching, what happened? Every time, whenever router receive the packet, right? Every time whenever the router receive the packet will be heated to CPU. And then CPU will perform the decision. It means that if your router, right, understood this concept, on this router, what happened? We have two things. One, we have a call as a RP, route processor. It's a little bit high level term. You will understand this terminology in a more depth when you're gonna talk about when I'm gonna talk about the service provider level, and when you comes to the CCI, then you will understand this terminology. But I'm just making a hint right now, so you will become familiar with this word. I can explain you, right, the meaning of process switching without the RP concept, but I just want to make sure that you go have a knowledge of this thing. RP is the stand for route processor, right? Or in a simple language, you can call this guy as a CPU. Simple language, right? Now, at the same time, on the router side, what happened? We have a SE. That's called as a switching engine, right? So RP is called as a route processor. Simple term, we can call this guy as a CPU, right? And we have a SE. That's called as a switch engine, right? So whenever the router will receive the packet, in the case of process switching, what happened? Whenever the router receive the, take example, we have a 0/0 interface, right? And we have a 0/1 as well on a single router, right? These are the internal components we have. So normally when you see the router, you don't see this thing, right? Because it's present on the hardware side. So on a router side, we have a multiple component, huge components we have. Okay, so whenever the router will receive the packet, take example, this is the packet we have received over there. So normally what happened, this packet, right? When this packet will receive by the router, what router will do that? The router will give this packet, I'm so sorry, how this happened. Okay. So when the router will receive this packet on this particular interface, what router will do that? It will give this packet to the RP, that's a CPU, and then RP will give this packet to the SC, the switch engine, then switch engine will forward this packet to the 0/1, right? That's my first packet. Same way, what happened when the router will receive the second packet, right? Router will receive the second packet on this particular interface. It will give this packet to whom? RP. RP will give this packet to the RP will perform all the lookups like routing lookups, TTL changes, checksum modify, and the layer 2 framing, everything they will do that. It will send this packet to the switch engine. And then what switch engine will do that? It will send this packet to the 0/1 interface. Again, we will receive the third packet, right? The third packet, what happened? It will receive on the 0/0 interface. It will give to the RP. RP will look up all these things like a routing lookup and everything. They will do that. It will give this packet to the switch engine, and then switch engine will place this packet on this particular interface. So try to understand every time whenever you will receive the packet has to look by the RP and CPU. So it means that if you receive the 1000 packet, right? If you receive the 1000 packet, right? This all 1000 packet will be hit to the CPU. It will handle by CPU. That's why it's called as a process switching. That's why it's called as a process switching, because in the process switching, what happened? All the packets, right, handled by the CPU only. All the lookups is done by the CPU only. So can you imagine that? Understand one concept. Your routing protocol, OSPF, your routing protocol, EIGRP, your routing protocol, BGP, NTP, SNMP, SSH, Telnet, MPLS, multicasting, quality of services, IPsec, DMVPN, and GRE, whatever the features that you are enabling on the router side, for that feature, what you need a CPU. You need a CPU. If I'm going to allocate all this packet forwarding, if I'm going to allocate all this packet forwarding only to the router CPU, right? Then what happened? We'll have a CPU for the another process. For example, if I'm going to run the BGP over there, and it will give you the error message, hey, you don't have enough CPU to run the BGP process. That's not a good thing, right? Because see, CPU means what? It's a main function, main brain of the router. And if you're going to allocate the main brain to just handling the packets, then how you can enable the another services on the router? Router doesn't mean that only forward the packet. Router means what? You need to enable the services. So that's why this process switching was not so popular, right? So that's why we have introduced the another switching mechanism is known as a fast switching. In the fast switching, what happened? Understand this concept. Your first packet will handle by CPU, and then fast switching, create a separate table that contain the flow information. Flow information is what? Like a source IP, destination IP, source port, destination port, and marking information. I'll tell you whatever the marking, what is the use of marking in the quality of service. The one flow means what? The one flow means simply you have a source IP, destination IP, source IP, destination IP. Then we have a source port, destination port. Then we have a port. What do we call? DSCP marking, right? And then we call as a transport layer protocol, like a TCP and UDP, L4 protocol. So if these are same, that's called as a one flow. If all the same, this called as a one flow. Like for example, source IP is 101, destination IP is 101, source port number is a 20, destination port is a 50, DSCP marking is a maybe AF11, right? And L4 protocol is a TCP. So that's called as a one flow. So what fast switching will do that? If you have a different IP and everything will be same, for example, your destination IP will be 101 or 3, right? And apart from everything will be same, that will call as a different flow. Flow means what? Everything will be same. So what he will do that in the fast switching, only your first packet of that particular flow will be handled by CPU. The 99 packets, right? 999 packets will handle by SE only. So basically, you look up, the main CPU lookup is only going to happen one time. The main CPU lookup is only going to happen one time. The 999 packets will go with the flow. So what fast switching will do that? In a fast switching, what happens once you enable the fast switching mechanism, it will create a one table. It will create a one table. And in that table, they will say that, hey, the flow something like that, 1 or 1, distance will be 1 or 2, right? It will go by the 0/1 interface. Of course, there will be multiple informs like a port number and those things, right? Same way 1.3 distance will be 8.8. It will go by the 0/1. Same way 1.4 distance will be 7.7. It will go by the 0/1 interface. So this flow table will be created on the router 1. It is also called as a cache table, fast cache table. So the first packet only hit by the RP, right? The remaining 999 packets will forwarded by the based on the table. So in that case, what happened? Understand, if you compare with this thing, right? In the first case, processing what happened, all the 1000 packets was handled by the CPU. But in the fast switching, what happened? Only one packet is handled by the CPU. The remaining 999 packets will handle by the SE only. The CPU not comes in the picture for this guy. CPU never comes in the picture for this guy. If you have a different flow, then CPU comes in the picture. But the major disadvantage of this flow is what? This flow will require the huge memory. Take example, if your router is going to receive the 10,000 different packets, like have a different source IP address, different destination IP address, then what happened? Then you will have a 10,000 flow entry in your cache table. And that again require the memory consumption. So again, the fast switching was not, see, it was a popular compared to the process switching, but again, the market has not adapted this guy so much. And finally, then Cisco introduced the mechanism is called as a SEP switching. SEP stands for Cisco Express Forwarding. What SEP is doing that? By default, SEP is enabled on Cisco router, right? And what SEP will we do that? In a SEP case, what happened, right? All my packets are not hit to the CPU. Only some exception packet will hit it to the CPU. So normally what happened in the SEP table, what SEP is going to do that? SEP basically create the two different types of table. One, it will create the fifth table. The SEP basically create the two types of table, right? Cisco Express forwarding, it create the fifth table. That's called as a forwarding information base. And other, it will create the adjacency table. FIB stand for forwarding information base. It's similar to the routing table. So normally, till this point, what you have learned, and what I said that, okay, whenever the router receives, guys, please pay attention to my words. I said that, hey, whenever the router receives the packet, it will perform the route lookup. And based on the route lookup, it will forward the packet to the next interface or maybe the next IP addresses, next hop IP addresses, right? That's I used to say that. But normally, a router, right, never forward the packet based on the routing table. Router forward the packet based on the fifth table, forwarding information based table. If your CEF is not enabled on the router, then the router will do the forwarding based on the routing lookup. If your CEF is there, then always Router will give the preference to the what? Routing table. For example, this is your router, right? And if your Ceph is enabled over there, then what happened? You have a two types of table. One is called the routing table. That's a 1.0.0 information, which is associated with the 0/0, right? So this is my routing table information. If I'm enabling the Ceph on this router, then what happened? Right? I will inherit, right? I will inherit the FIP information from the routing table. So all the routing information will be pushed to the FIP table. That's a 1.0.0.0 associated with the 0/0. So whenever the router will receive the packet that has a source will be x.x.x.x, destination 1.1.1, right? I will look up the FIP table, not the routing table. I will look up the FIP table, not the routing table. Routing table only comes in the picture when the FIP is no more. When the FIP is no more, it means that there's no Ceph. Then I will perform the lookup in the routing table. And that's how we save the lots of memory and CPU. In the Ceph forwarding, what happened? My packets are not hit to the CPU. Only the exceptional packet is hit to the CPU. Exceptional packet means what? Routing update packet. The packet that has a enabled with the quality of services. Policy-based routing, if you remember that, right? We did the policy, we apply the policy. In that case, the CPU will be handled, not the FIP is going to handle that packet. So all my transit traffic through the packet, right? Through the packet, all my transit traffic will be handled by the FIB only, not the CPU. So that's where we can improve the router performance. So this Ceph has improved the router performance. So initially it was a switching mechanism was what? Initially it was a process switching, then it comes to the fast switching, and then finally it comes to the Ceph. These all called are these all called are what? These all called are the IP switching mechanism. Why I call this guy the IP switching? Because in every cases, the process switching, if you do the fast switching, if you do the Ceph switching, in all the case, we are only doing the IP switching. We are placing the packet from one interface to the another interface. So your FIP table, it maintains your layer 3 information. Whereas it's your adjacency table, you maintain your layer 2 information. So FIP table, it's a mirror copy. It's a mirror copy of your routing table. It's a mirror copy of your routing table. So whatever the routes are present in your routing table, right? Whatever the routes are present in your routing table, the same information, the same ditto information will be there in your FIP table. For example, if your router has a 1.0.0.0/8, if you're 2.0.0/8, and if you're 3.0.0/8 information in your routing table, this is routing table, take example, right? Same information will be placed in the FIP table. Same ditto. So this is my FIP table, forwarding information base. That's going to maintain the layer 3 information. If I'm going to take example, if I'm going to remove this guy, 1.0.0/8 from the routing table, automatically information will be removed from the SEP table. If I'm going to add the 8.0.0.0, what routing table will do that? It will share this information to the FIP table. So whenever the router will receive the packet, source x dot and distance 8.8.8, it will look up in the FIP table and forward the packet to the another person. So if you see a router, that's never comes in the picture. The CPU never comes in the picture. It will forwarding based on the FIP table. Somehow, take example, if the FIP doesn't have this information, take example, if the FIP doesn't have this information, then, right, then it will perform the lookup in the routing table and CPU comes in the picture. So all the layer 3 information is maintained by the FIP table and the layer 2 is maintained by the adjacency table. So all your MAC information like ARP process, everything is maintained in the adjacency table. So by default, the Ceph is enabled. You don't enable this thing. But the process switching and fast switching, nowadays we are not using it. It's not used. Yeah, there is a some situation, right? A very, very advanced level. Even the most of the people are not understand this point in the even the CCI enterprise level. So in some situation, right, a router do the process switching as well. In some situation level, the router do the fast switching, right? But in very rare scenario, rare means rare scenario. Like you can say that in the 1%, not even the 1%, 0.2 and 3%, some scenarios there, like a DMVPN, right? Phase two, if I talk about it, that's a advanced level. There are still Ceph is enabled, right? But the first packet is going through the process switching, right? So still Ceph is disabled, but the packet is handled by the CPU. That's why we call it the process switching. But by default, the Ceph is enabled. And if you remember that I told you that in the URPF case, unicast reverse path forwarding, right? Your Ceph must be enabled. If your Ceph is not enabled, you cannot do the URPF. Even there's some scenario like a MPLS. In an MPLS, right, Ceph must be there. If your Ceph is not there, you cannot you cannot do the MPLS. There is a reason behind it. So I'll show you the few things about the Ceph. Let me show you the two routers is enough, right? All this comes in the IP switching mechanism. Whenever the switching word comes in the picture, guys, remember always one thing. Switching means what? Placing the packet from one interface to the other interface. Now, which packet? IP packet. That's why it's called the IP switching. If you guys are belongs to the if you guys have work on the what we call ASR router, service provider or ASR, or maybe the NCS box, that's a service provider boxes, right? And even if you work for the data center Nexus, right? So in the Nexus, we have a soup engine, supervisor engine, and that's you can compare with the route processor. That's a CPU. And if you work with the service provider, in the service provider, we have a RP, or you can call it the RSP as well. Because you will not heard this term RP, it had processor in the complete CCI interface, and even you will not find in the book as well, because the word is a very high level, okay, and normally it's not used in the CCI enterprise. So when you go with the high level things, right, SP and the data center, you may encounter this thing. Just to make a familiar with the words, I use the RP, or either I can say that instead of the RP, I can say the CPU. So whatever the terminology you are used to it, just say that CPU or makes the RP. So whenever the interview will ask you, just say that CPU, not the RP, right? Because many times even the interview doesn't have an idea of this thing. So if you see the interface 0/0, I'm not going to do anything. I'll show you the first thing right now. So IP set. If you see that, I have a set table, right? If you the show IP route, I have a route table as well. So what I can do that, I'll say the debug IP routing and debug IP set. And I'm going to enable the, I'm going to enable the IP on this particular interface just to show you one thing. Okay. And I'll just go to the router one and say that I haven't any debug IP set events. There is a command is called, yeah, that will show you. Debug IP set table. Yeah, table is there. So interface 0/0, if you see that IP address will be 101.1/8, no shutdown. You will see that I'm adding this network in my routing table, right? And why it's not showing the sub table, man? Let me do this. I just want to show you the output in the debug. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. 0/0. I can show you the in the CLI verification command, but I just want to show you the output. One minute, hold up. Let me check in this version. Maybe I can show you that. So interface zeros. Okay. Debug IP sep debug sep debug. Okay, the command is little different. It's very yeah. Debug IP dot. Depending on the version by version, it's very so IP address 101. So now 3 interface. If you see, can you see that? So I'm adding this route in my routing table, right? As it added in the routing table, 100.0.0.0/8 in the routing table. The SEP is a mirror copy of the routing table. I will push this information in the SEP table too. That's called the fib table, we can call it. Right. So I just added in the routing table, it will add in the fib table, SEP table as well as. Right. Now let's come back to the same behavior on the router one. This guy. So I don't need to, I just want to show you the output, that's all. Okay, so on the router one, I just added this interface. On the router two, let's add this guy as well. So if you see that show IP root, I have a 1.0.0/8 route, right? And if you use the show IP set, I have this guy as well. I have this information in my routing table. On router two, I am on the router two right now. Same time, what happens? Same information will be there over in the SEP table as well, attached by the 0/0 interface. If you look for the MAC information, so interface 0/0 include BIA. Let me write on the MAC address for each guy. So this is the MAC of R2 interface. And if you see the MAC of this guy as well, R1. That's router one. So if you see in the router one, if you go in the router two again back, so this is my fib table. This is called the FIB table, forwarding information base. So basically your router is forwarding the packet based on this table. If you see the adjacency table right now, ping 101. So that's my adjacency table. That self create the two table. One is fib and another adjacency. So so in the router two, you can see that my adjacency means what? My adjacent router information. So in the router two is saying that my adjacent router is a 101, right? And if you see the MAC address, so the CA012E1, right? 8000000, right? Till this point, right? And then after that, we have this is the MAC address of my neighbor one. I'm on the router 2 right now. Then after that, we have a CA01 to this guy till this point. We have a this guy, R2 MAC address. And then after that, we have a ether type information. So in the adjacency table, we have a MAC information of the layer 2. So we have a source MAC, plus we have a destination MAC, right? And then we have a ether type. So all the information we have in the layer 2 table. So for the layer 2, I'm not going to look for the ARP table now. Normally what happens if you don't have a SEP? If you don't have a SEP, then you don't have a fib table. You don't have adjacency table. In that case, you need to do the lookup in the routing table and ARP table. But after creating the SEP, right, you have this thing on the routing. So if I'm going to disable this guy, take example as the no IP SEP. So you can disable the SEP on a per interface basis and the global as well. So though there's a two ways to enable and disable the SEF. Either you can go in the global basis or either you can go in the interface basis, right? So I can say the no IP SEF means what? I'm going to disable the SEF from the complete router. So if you see the show IP SEF now, it will show you that there is no SEF. So adjacency routing. Sorry, detail. Still have. It must not be have this information. I don't know why it's showing that. It must not be have. It must not be have this information. So if you see that Ceph is not running, so you will not have a Ceph table. But if I'm going to enable the Ceph back again, right? So in this case, what happened? The router will do the routing lookup and the process comes in the picture. So if I'm going to enable the Ceph, you can also enable the Ceph. So now once I enable the Ceph, all this information will be there in the Ceph table now. So whatever the information in your routing table, they will just copy in the Ceph table, and based on the Ceph table, they are forwarding the packet. But there is a problem. There is a problem. Problem is what? The problem of this all switching mechanism is what? The common problem, if I talk about the common problem of all this switching mechanism, that the switching mechanism that we have seen now. Then we have a fast switching. Then we have process switch. Sorry, the first will be go with the process switch. Just ignore it. Okay, then we have a cell. The common problem of this all switching mechanism, right, is what? They are just doing the IP lookup. Which IP lookup? Destination IP lookup. In the destination, which IP lookup? 32-bit lookup. 32-bit lookup. That's our first issues, right? Second issue, if I talk about, always what happened whenever the router will receive the packet, right? Whenever the router will receive the packet, doesn't matter what source will be there. Destination is 1.1.1.1. You tell me one thing. If there is a router over there, and if this router has a 1.0.0.0/8, then we have a 1.1.1.0/24. Then we have a 0.0.0.0/0, and then we have a 1.1.1.1.1/32. So this is associated with the 0/0. This is associated with the 0/1. This is associated with the 0/2. This is associated with the 0/3. So tell me one thing. If the router will receive this packet where we have a destination is 1.1, what router will do that? Which interface they will use to forward the packet? In the this is my routing table. You tell me. The first issue with the all this switching mechanism is try to understand this part, guys. The basic problem, right? The basic problem of this switching mechanism is what? The first thing is they are doing the 32-bit lookup. That's the first. Second problem is what? You need to find the answer. You tell me first thing. Whenever the router will receive this packet, it has a destination 10101. Which interface they will use to forward the packet?
I think it will check the 1.1.1.1/32.
Why? It's a correct answer, but why?
Because the 1.1.1 is the same, but we have the source address as and S of X. But
No,
the,
I'll tell you what
but
happened.
the
Yeah, it's a
destination
correct
address is
answer. It's a correct
1.1.1.
answer. It's a correct answer because of the longest prefix. Longest
Oh, okay.
prefix match rule.
The longest prefix. Okay.
Longest prefix means it will look for the longest subnet mask. So if you see the subnet mask, see this one can match with the one of this guy, can match with the this guy, can match with the this guy, can match with the this guy as well. But
Okay.
who has the longest prefix match? /32.
Okay.
These are just higher subnet mask information. This is a very important question in an interview.
Okay.
Very, very important.
Longest
Right?
prefix.
So it will look for the longest prefix match. Now, guys, attention. It's very important now. Let's go with a little bit more detail. you will understand the reason why the MPLS comes in the picture. The first you understood, right? That 32-bit lookup. 32-bit lookup means what? 32-bit. Every time it will do the layer 3 lookup, right? Now, if there is a router 1, there is a router 2, there is a router 3, right? Same behavior I'm taking that. So I will do that like this. Huh? Nahi. So, nahi. So if you have a source IP address will be x dot x dot x dot x and distance will be 10101, right? That's a source info and distance info. So R1 has a route table. So 100.0.0. I'll say the 0/0 we have this guy, 0/0 we have this guy, 0/1 this guy, and 0/0 this guy. 1.0/0 associated with the 1.0/0/8 we have. Then we have this guy will go with the 1.0/0 and /16 we have seen 0/0. Doesn't matter right now. Hypothetically we are thinking that same information will have what this guy. So router 2 also have routing information. So 1.0/0/0, right? They have associated with the 0/0 right now. 0.0/0/0/0 associated with the 0/0 right now. This is the /8 we have, right? Then this guy we have a 1.0/0, not 1.1.1.1/32, and then we have 1.0/0/0/8. Now understand this concept right now. So whenever the router will receive this packet, if the router 1 will receive this packet, what router will do that? Router 1 will look up the longest prefix match. And based on the longest prefix match, it will select this route. When router 2 will receive this packet, same destination 10101, it will look up the longest prefix match and look for the /8. Now, because it will start with the /32, /30, and then 30, then 29, then 28, 24, 25, 20s, then 15, then it comes to the 14, then it comes to the 10, then it will come to the 8, and it will match for this guy, right? If the 8 is not there, then it will look up for the default route, right? So again, router 2 will do the longest prefix match. When it comes to the router 3 now, right? What router 3 will do that? It will start with the /32 and it match with this guy. So can you see that every router is doing the longest prefix match lookup? Every router. Do you think is there any delay in the longest prefix match lookup? It will do the fast lookup because of /32. It will do the little delay over there, /24, and it will have a more delay over there, /8. Sorry, yeah, /8 more delay. Because it will start the looking for the /32, /30, 24, 18, 16, 15, 10, 11, then 9, then it comes to the 8. And take example, if the 8 is not there, it will match to the default route. That's why it's called as a default route is a less desirable route. Remember one thing. Recently, the Keras has, I don't know, Keras or somewhere, maybe someone else, right, has put the one one image right in the group. Then I say that it's the default route from the DHCP. Do you know why the DHCP is giving the default route with the 80 to 54? Why it's not giving the 80 with the 1 and why not the 2? The reason he's giving the 80 to 54 so that the ISP is saying to the customer, hey, you know one thing, if you don't have a default route in your routing table, you can use my default route. You can use my default route. That's why 80 to 54 is there. Normally, what is the AD of the static route? 1, right? Which is reserved in the Cisco routing table. Not I'm talking about the Juniper. Juniper has a different AD value. But normally, when you when you take a default route from the DHCP, it has a 254 AD. The reason is that it's just giving you the backup perspective. That's why it's called as a less desired route because it has a subnet mask as 0 over there. So the first problem, if you look for the IP switching, like a process switching, if you go with the SEF and the fast switching, the common problem is what? They are doing the 32-bit lookup. Second problem, L3 lookup. Every time L3 is going up, so it comes in the picture. L3 means what? Route must be there, right? Route must be there in your routing table, must be there. If you don't have it out, you cannot send the packet. Listen to me. If you don't have it out, the meaning of this line is what? If you don't have it out, You cannot send the packet, right? Third problem, longest prefix match. The fourth issue, whenever the router will receive the huge number of packets and it will perform the longest prefix match rule every time because it comes to the /32 and /30 and so on, your performance will be degraded. Your performance will be degraded. These are the major issues. Okay, I'm just again giving you the basic overview why we are going for the MPLS. These are the major issues, right? That's why we are moving towards the MPLS part. Okay, again, these are not all issues. These are the minor one that you understood right now. Because all these things we have seen. But major, if I talk about, there's a many reasons why we are moving to the MPLS. Many reasons. So you can explain these reasons and definitely no one will reject you from the interview. But even these reasons, people don't know about this thing. If somebody will ask you, why do we need a MPLS? You know what they will say that, okay, because MPLS is doing the faster lookup. MPLS improve the router performance. MPLS you can use for the VPN. These things are written in the book, man. MPLS used for the VPN. That's an application of the MPLS. MPLS VPN, MPLS traffic engineering. These are the MPLS quality of services, right? These are the application of the MPLS. But the major reason why we are moving toward the MPLS, this is the reason. 32-bit lookup. There's no fixed length. Can you see that? Is there any fixed length over there? Is there any fixed length? If you see in the routing table, check the routing table. Do you see the any fixed length over there? Fixed length means what? Fixed submit pass? No. Everyone has a different. If you don't have this one, I can forward the packet via this one. If you don't have this one, I can forward the packet via this one. There is no fixed length. There is no fixed length. And that's why we introduced the mechanism is called a fixed length forwarding. Okay, I'll tell you one thing. This is the issue only with the happening with the layer 3. On a layer 2, we don't have any issue, man. Layer 2 has a fixed length, 48-bit MAC address. Can you do the subnetting of the MAC address? No, we cannot do the subnetting of the MAC address, the fixed one. A flat. But you can do the subnetting of the IP addresses. Right? You can do the subnetting of the IP addresses. That's why it's not a fixed length. Because your /8, 1.0.0/8 can become the /10 and can become the /24 as well, can become the /32 as well. No fixed length. So that's why, so on the layer 2, we don't have an issue. The issue comes in the layer 3. And that's why we introduced the fixed length forwarding. And that fixed length forwarding is introduced by the label forwarding. And this label forwarding is known as a MPLS. So in MPLS, what happened? In MPLS, what happened? Each route, MPLS stand for, first of all, one more thing. This is not a protocol. Okay? Never say that this is the protocol. I have seen that many person is saying that, okay, CEF is a protocol. If the CEF protocol is not enabled, CEF is not a protocol, it's a switching mechanism. Okay? Now, if I come to the MPLS, what do you think? Let me give the full form of the MPLS right now. MPLS, multi-protocol. Label switching. What do you think? Is this a protocol or it's a label switching mechanism? Is this a protocol or a label switching mechanism?
It is a label switching mechanism.
It's a label switching mechanism. It's not a protocol. Don't say that it's a protocol. Never say it's a protocol. People are used to say that it's a protocol because the word is saying the protocol. Remember the VTP protocol in the layer 2, VLAN. We did this practical, right? VLAN trunking protocol. What people are used to say that BTP is a trunking protocol. BTP is not a trunking protocol, dude. To exchange the packet of the BTP, we need a trunk. Sometimes this name will confuse you. Got it? So first of all, MPLS is not a protocol. It's a label switching mechanism. Right? Under this MPLS, we have a protocol. We'll see that. Don't worry about that. So in MPLS, what happened? Now we have a label forwarding. So instead of doing the 32-bit lookup, now here we have a 20-bit of label. The first issue has a resolved. I have improved the data performance. How? Instead of the 32-bit lookup, now I have a 22-bit lookup, 20-bit lookup. Now, second thing is that is the L3 lookup, right? Now what happened? We have a label 2.5 lookup. It means that no need to jump on the layer 3, no need to jump on the network layer. If my issue got resolved on my second 2.5 layer, right, between the data and network, if my issue got resolved over here, take example, we have a network layer, we have a then data link layer, and then in between we have a MPLS. And that's why it's called as a seam header as well. Why I call it a seam header? Seam is what? It's a plate. If you look for the seam diagram, I was showing the hub to someone. Seam, what do we call seam? So look for the seam. Can you see that? This is the seam that you can place this guy. It's a small particle, right? A small component. You can just place this guy into the any places, right? So I place the MPLS into the in between of network and the data link layer. So now the label forwarding, the 20-bit of label that we have, it's based on the layer 2.5. So the packet comes over here, and based on that, it will forward the packet to the next interface. No need to go on the network layer. I can save the huge resources. Third part, longest prefix match lookup. Do I need longest prefix now? It's a fixed label, man. It's a fixed label. No need to do the longest prefix match now. You cannot do the submitting of the label. It's a fixed length, 20-bit.
Okay.
Performance will be amazed. And now in this case, what happened? Layer 3 lookup, right? That must be present in the MPLS in some scenario. In some scenario of the MPLS, like a example, MPLS VPN. This is the one of the application of the MPLS. We'll discuss in the CCI part. In that case, router doesn't have it out, and router can still forward the packet. Router doesn't have it out, but still they can forward the packet. It means that if the router doesn't have a 1.0.0 information, but we do have ability, we can send the packet with the help of MPLS. That's a beauty part we have. Imagine you don't have a 10,000 route in your routing table, but still you can send the traffic. How? Based on the label. So some router has it out, some router doesn't have it out in the case of MPLS. That's a beauty. So normally what happened, what MPLS is doing that, it's a label forwarding mechanism. It's one of the switching mechanism. The only thing is that, right, here the switching is done based on the label, right? Previously, it was an IP switching mechanism. That was a set. Now I just replace the IP with the label. I just replace the IP with the label. Now, again, you have a question, hey, law, then why it's called as a multi-protocol? The meaning of multi-protocol over here, is what? It can support the various protocol. Like you can do with the layer 2, you can do with the layer 3, you can do with the what we call frame relay, right? You can do with the ATM. That's an older uh, technology, but now also we are using the ATM as well, right? So we can, this guy can support the multi-layer. You can support the PPP, you can support the SDLC serial link as well. Anything you can do with MPLS, anything. That's the meaning of multi-protocol. Multi-protocol means support the multi-protocol. You can use the MPLS in the various scenarios. I know it will be confusing right now, but don't worry, it will become a very handy whenever you go in the like in a high level. It will become the handy. My main motive is here is what I just want to explain you the meaning of multi-protocol. The meaning of multi-protocol, it doesn't mean that it's a protocol. It support the multi-protocol. It support the multi-protocol. For example, I have example for you. OSPF is a pure IP-based protocol. It cannot support any other routing protocol. Sorry, it cannot support any other addressing, right? Whereas the EAGRP, it's IP protocol, and it can support by the Apple Talk as well. It can support by the IPX as well. Same way, so we can call this guy EAGRP is a multi-protocol. Same way, the MPLS is a multi-protocol. Now, in an MPLS, what happened? As I mentioned, that's a label forwarding. So each route has a unique label. 20. This guy has a 30. This guy has a maybe 18. This guy has a maybe 19. So whatever the routes is present in a routing table, each route has a label. So maybe this is the router number one. Router number one has a routing table. This guy has a label. For example, router number two, we have router two have a same label, a route over there, 1.0.0, 2.0.0, and 4.0.0, and 5.0.0. Understand this guy? So maybe the one dot, maybe there are two. This is routing table. They can use the 1.0, maybe the 14 label. They can use the 30 label as well. They can use the 19 label, and they can use the 18 label. Can you see that over there? What's happening? It's totally unique, right? The label is totally, this is the R2 and this is the R1. Both are the unique label. But the 2.0, I have a 30, and 2.0, I have a 30. What I'm trying to say that within the routing table, right? Can you see the labels are unique? Right? Labels are unique. Each route is going to stand the different labels. Between the routing tables, labels can be duplicated. Between the routing tables, labels can be duplicated. So now we can see that labels are local to the router. Local to the router in the sense of what? By using this example, we can see that, right? Labels are local to the router means what? The labels are locally unique, but not the remotely. So this can be happen, and this can also will be happen. A duplicate you can see on the between the routers. Now, what is the range of the label we have? So as I mentioned, that's a 2 to or 20 bit of label we have. This is the labels range we have. So start with the 16 and end with this range. Why 16? Because till 0 to 15, these labels are reserved. Reserved for some special use. You will see that in the CCNA, but not now, because it's a very high level of things. So 0 to 15 labels are reserved. And from 16 to 20 bit, labels are dynamically assigned. Now, the thing is that who is going to assign the label? That MPLS can assign the label? No. In an MPLS, we have a protocol that's called a TDP protocol. TDP stands for Tag Distribution Protocol. This protocol, right, has a responsibility to assign the label and share the label information. For example, I have a label and Keras has a label. So I will say my label to the Keras, and Keras will say the own label to me with the help of what? TTP protocol, Tag Distribution Protocol. But this protocol we are not using nowadays. It's a totally obsolete protocol. it is introduced by the Cisco, and in 1998. So in the 1998, the first time the MPLS was used on the Cisco router. On that time, the TTP was the reason to not using the TTP. The first issue with the TTP is what it's doing the broadcasting. It means that the update will be sent on the broadcast address. Second issue is that what TTP is a Cisco protocol. This is the two issues we have. That's why we are not using the TDP to assign the label and to distribute the label information. We have a protocol which is known as a LDP, label distribution protocol. Now I'll tell you one thing. Okay, maybe it's a myth or maybe what. I read some many documents, right? And again, I was not there on the time. So yeah, so many documents say that key like TDP was first came in the picture, and then LDP, which is the IEEE standard protocol, right? And it is doing the multicast address. We'll see that what are the multicast address we have. So it's a IEEE standard. That's a beauty part. It's a multicast address. So LDP inherit all the features, right? It leverage all the features from the TDP. Again, not pretty sure. It is written in the some documents. Okay. So no need to tell somebody. I just tell you. Okay. I read some documents. It was mentioned somewhere. Maybe it happened. Maybe not. I'm not pretty sure about it. Right. So yeah, LDP. Someone said that LDP. They copied all the information from the TDP. Of course, the TDP first comes in the picture, then LDP. So maybe because many things, even the IEEE standard, they copied from the Cisco, and many things Cisco copied from the IEEE standard, right? So it could be happen. There's no big deal. So LDP is a protocol. So what happened? This protocol is gonna assign the label and distribute the label information to the neighboring router. Right. So this is the dynamically assignment. Again, remember one thing. This is the dynamically assignment. Dynamically assignment is what? We have a protocol of it. That's a protocol name is a LDP protocol. Now you may have a question. Can I assign the manually label, the statically label? You may assign. You can assign the statically label. But in the real world production, we are not doing that. We are doing the manually mechanism. But in some scenario, you can do the static label as well. Okay. Just for your information, nothing else. Okay. Now I'll show you how you can. It's a very pretty simple command, man, to enable the MPLS, nothing else. It's not a rocket science. I already have I think so. For the MPLS, your SEP must be enabled. If your SEP is not enabled, you cannot achieve the MPLS. Okay. Because in the MPLS, normally what happened, right? Your MPLS, normally what happened, you have a LFIB table, label forwarding information based table, right? Right? You have a LFIB table, and this LFIB table is created by the FIB table. And this FIB table is created by the whom? SEF is gonna create the FIB table. So if your SEF is there, then your FIB is there. And if your FIB is there, then you will have a LFIB table. LFIB means what? FIB means what? Forwarding information base that contain the IPv4 route information. It's a label forwarding information base that contain the label information and the route information plus IPv4. So L means label, FIB means IPv4. So you have a 1 or 0 or 0 or 0 with the label over there 50. That's why it's called as LFIB table. So if your SEF is there, then you will have a FIB. If your FIB is there, then you will have a LFIB. So I hope you understand why do we need a SEF. Okay. One more thing that's very important. So LDP protocol is one of the protocol, not I can say the only one protocol. LDP is one of the protocol that's gonna use the UDP TCP as well. Port number, come on, 646. TDP is using the 711. TDP is using the 711. Nobody will ask you what is like a port number of the TDP. It's a totally obsolete. Yeah, sometimes they will ask you what is the difference between the TDP and LDP. So you may say that, right? TDP is a Cisco provided protocol. It is using the broadcasting, right? And the port number 711. And TDP has a lots of disadvantages, right? And LDP is a it's IEEE standard protocol. It's using port number 646 and it uses the multicast address. So port number 646. So to discover the neighbor, we use UDP, of course, right? And to establish the neighbor, we use TCP. Simple logic, right? Because when we're gonna establish the neighbor, I need a reliability. And when the reliability comes in the picture, I need a TCP protocol, right? So this is gonna happen unicast. This is gonna happen multicast. Because of course, right, when I'm gonna discover the neighbor, I have no idea who's my neighbor. So I'm gonna send the discovery packet on the multicast address, like a OSPF in AGRP. I hope my IP configuration must be there. So let me do one thing. I'm better to explain you the topology right now. You can see that this is the Cisco Delhi I have, okay, and which has a one network 6.6.6.6. And I have a Cisco Bangalore. I have a two branch office in a two different location. And this is the service provider I have, router 1, router 2, router 3, router 4, router 5 is the service provider router, right? And basically what happened, service provider is giving the MPLS connectivity to the customer. So service provider can give you the two connectivity, right? On a layer 3 perspective, I talk about. So on the layer 3 perspective, they will give the two connectivity. One, they will give you the connectivity of the IP. Another, they will give you the connectivity of the MPLS. So for the MPLS, you need to pay some money extra. It's because it's a private connection for you. And for the IP, right, you don't need to pay the lots of money. It's a fine. You can pay the normal money. But for the MPLS, it's a special charge because MPLS give you the faster services as well, right? Again, just for your understanding point of view, because in a CCI, you will understand the MPLS in the 30 hours of the classes. So it's a huge thing. Come on. Meantime, I'll do the IP configuration, man. So the step one is what? Configure the IP step. Configure IP addresses. On out of 6, you can see that I have customer. So interface, come on. Interface 0/0 IP address will be, I think so. I'm using the submit. Okay, let's go with the 32. R1 I have 150 interface 0/0. 16.1. And then I have a look back as well. /22. 12.1. R2. Let's copy and paste it. Let's go with the 12.2. Just go with the 2.2, and just go with the 23. Perfect, right? And R3 we have now. This guy go with the 23.3. This guy go with the 3.3.3. This guy go with the 3. Then we have R4. This guy go with the 24. Guys, please pay attention on the IP configuration. It's very important. 34.4. This guy go with the 4.4.4. This guy go with the 4.4. See, you need to understand why we need a MPLS. Because see, you can find the lots of video on the YouTube, like a configuration of the MPLS and those things, everything you can find it. The main part of the theory part, that's a very interesting one that you need to focus. Configuration, these things you can easily find on the internet. On the R5, we have 45 of 5 and 5. This guy go with the again 57.5. Okay, man. So router 6 is came up. Why it's not other bits? I think so. IP is my predefined. I have saved the configuration mostly. So this is the router 6 I have. Let me close this, not close. Let me check whatever the IP configuration I have on the router 1. So IP interface B. Oh, I have a configuration. You can see the router 1. On router 6, if you see that. On router 6 also we have router 2. Now let's go back. Router 2. So IP interface B. I have a 12 and 23 or 2. Or 3 we have 23 and 34.3 and 3.3.3. After 34 and 45 and 4.4.4. R5. 45, 57. That's perfect one. And R6. R6 is done. R7. 57 or 7 and 7 or 7. So let me copy and paste it. I haven't tried the 7 right. Okay, let's run the routing protocol. Router 1, I have router agent as the network will be 12.0. Network will be 101. Network will be 16.0. No auto sum. I don't need to do any with the by default auto sum is stable in the newer ICE version. So that's fine. So between the router, we need to run the routing protocol because if I'm not going to run the routing protocol, they will not exchange the route. Right? That's our second thing. So step number 2 is what? Enable IP reachability. So I just need a reachability. You can do anything, and you can go with the OSP up. You can go with the RIP. Anything is fine. I just need a reachability. You can go with the static data as well. So 23.0. R2 is done. R3 now we have. So between the customer and service port, right, you can see that right now. Between the customer and service port, I'm using the same protocol entirely right now, EHGRP. You can use the different, between this guy to this guy, you can use the BGP, right? And here to here, I can use the EHGRP, right? And here to here, you can use the AN BGP. So, but if you're going to use the BGP, then you need to do the redistribution on this guy, right? So router 4. I'm making a simple so that you can understand the behavior of the MPLS. 34.0. 45.0. 57.0. 5550. And it's like 45.0. R7 now we have 57.0. And that's all, man, on R7 now. So let's do with the R7 configuration first of all. हाँ कर दिया क्या? क्या रेट? अच्छा, हाँ तो पर्सनल लैपटॉप खोल जाएगा तेरे। हाँ तो उस पर नेक्सस डाल दे। ठीक है, XR V7.1 जो मैंने तुझे दिया है वो डाल दे। ठीक है, एंड एक नॉट XR, एक तो XR 771 होगा समथिंग जो मैं तुझे पिक्चर दिया होगा, एंड एक XR V होगा, और 761 दैट XR राइट। हाँ, और एक नेक्सस डाल दे सो अभी, 9 के, नेक्सस 9 के। हाँ 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 हाँ, यूनिटी को बिजनेस पेज, और सर्च कर लेना नेक्सस मिल रहा है नहीं, तो उस पे एड ऑन्स पे क्लिक कर, एड ऑन्स पे तुझे मिल जाएगा पेज में। एड ऑन्स से नेक्स्ट वाले पेज पे क्लिक कर, उस पे लिंक होगा ना साइड में, वो हायरार्की फॉलो कर ले उसको, मिल जाएगा तुझे। हम्म 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 हम्म, हाँ 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 हाँ, AVNG की डालना है, ये पुनीत पुनीत का सर्वर है। हम्म। हाँ हाँ हाँ, तो उस पर इंस्टॉल कर देना और कॉपी का पेस्ट कर दे। कॉपी या तो इस पे उसी उसी को क्या कर ले, या तो कोई मेल आईडी खोल दे उस पर अपना। ठीक है, वो सर्वर सिक्योर है। हम लोग के अलावा कोई यूज नहीं करते, मैं तू और नहीं भी यूज करते उसके अलावा कोई यूज करता सर्वर। हम्म हम्म, हाँ उसी में डालना है इवेंचुअली, जैसे मेरे पे डाला था। राइट, चलो ठीक, ठीक चलो। Hey, so the reason that I put the 0 just put the wildcard mask to just advertise the five only single IP addresses. Okay, so router 1, router 2. So if you see router now, router 6, I haven't
Okay.
the router 6. You understood, right? I just advertised a single IP address, so that's why. That's why I put the this guy. I'm getting the lots of call today. I know why. Hello, hello. So network, I have a what we call 16.0. All then R6 now we have. Bingo. Done. 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 All done. So if you see on the router 6, I have a out in my routing table. So IP route agent on the router 6, you can see that I have a 7777, right? And I can send the packet. All going good. So if you see that this packet is doing the route lookup right now, the 32-bit lookup. All the router is doing the 32-bit lookup, 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 all the router. Hop by hop, 32-bit lookup is doing that. I want to do the MPLS lookup, right? 20-bit lookup. So I need to assign the MPLS. So simple command to go with the MPLS is what? MPLS, you need to say the label protocol is what? Which label protocol you're going to use? TTP and LDP. I said the LDP. Now, do I need this command? No, it's an optional command. But just for the practice right now, you need to do that. MPLS LDP. I need to select who will be the router ID. Because like a OSPF, we have a route ID, EHRP, we have a route ID. In a LDP protocol, we also have a route ID. That is known as the LDP ID. So LDP, MPLS LDP ID, look back number one, right? Let me check it out. Is the command one? MPLS, MPLS, MPLS LDP. What's the command for that one, man? Plus LDP, and so other command I forget, man. How did I? LDP route ID. Sorry. Wait.
Is having a router.
Yeah, it's a route ID. So look back number one. So here you're not gonna assign the x dot x dot x dot x like a OSP you did it, right? You just need to mention the look back number. And again, is it a mandatory command? It's an optional command. These two commands are not mandatory. And now I can see the interface 1/0. On which interface I'm going to enable the MPLS? I just said the MPLS ID. That's all I'm done, man. On R2 as well, same command. How many interface we have? So if you see that, you need to only enable the MPLS on the service port interface. This guy, 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 this guy. On the customer facing, no MPLS. They are just doing the IPv4. Why not? There is a security reason. Leave it. There is a security reason is there. So somebody will tell you, hey, no, 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 you are not going to enable the MPLS. Why? Because it's a customer. So why can't I enable the customer on the MPLS? We can, but there's a security reason is that. That's why we're not going to enable the MPLS. If you're going to enable the MPLS on this particular interface, then what happened? Right? They can make any attack to the complete service provider. Customer can, because for the service provider, customer is like what? Untrusted network, right? On a router 3. So on a route 2 also we need to enable the MPLS on this particular interface 0/0 as well, right? On router 3, do I need to enable this command? No, man, I don't need to enable this command. Interface 0/0, I just need to enable this guy, MPLS, that's all. On router 4, I can just enable it. Router 5 and router 7. On router 6, I just consider interface 0/0 MPLS icon. So if you see one thing, this two command I just enable on the router 1 and router 2. That's all. As I mentioned, that's an optional command. It's not a mandatory command. Okay, if I'm just gonna put the command on R3 interface 0/0 MPLS IP, automatically this interface will be a part of the LDP, because LDP, right, is by default enabled once you enable the MPLS IP command. And automatically what happened, they will select the router ID, LDP ID, right, which is the highest interface IP address of the loopback. If you don't have a loopback, then it will go with the physical interface. So now all done, man. So if you go on the router 1, all done on the router 2 as well. So if you see, they will form the navigation. The navigation is the LDP navigation. So if you capture this link, so you will see that the protocol is going to use the multicast address instead of the broadcasting. The TDP use the broadcast. This is your task. The port number 646. It's a label distribution protocol we have. It's a hello packet. The task for you is what? The task is this multicast address 224.0.0.2. Is it used by the someone else as well in the network? This is LDP is used for the 224.0.0.2. Is it also used by the some other RAR protocol in networking? Just check it and let me know as well. Okay, so now we are done. Let's go in the R3. So 224.0.0.2, it's used by someone else as well. Now you need to find which one, who is using the same multicast address. R4 now. And R5, someone put the answer, I think. And R6, I don't need MPLS, man. On R5, I just need MPLS on the this interface. 0/0. No? Okay, then you need to find it. So R5 has formed the neighborship with R4. Can you see that? LDP neighborship, right? This 0, it's meaning in the label space, right? So basically the size of this 0 is a 2 byte. Okay, the size of LDP is this is the 4 byte. So LDP identified, LDP ID that you have, it's a 6 byte. Whereas if you check your router ID, it's a 4 byte. Label space, we'll see that. It's a very big lecture on the label space. Now you can check on the router 2, router 3 as well, router 1 as well. So on the router 1, if you put the command, so MPLS LDP interface, so MPLS LDP, so MPLS LDP interface, it will show you my interface has been enabled with LDP. It's operational. Static means have I done with the static label? No. These two things comes in the picture when you're gonna do the MPLS VPN and traffic engineering. Then these two things comes in the picture. It's a application of the MPLS. So you can use the MPLS. So right now the MPLS that I have used, it's called as MPLS Unicast. But apart from Unicast, we have a use case of the MPLS as a VPN, MPLS layer 3 VPN, MPLS traffic engineering, right? You can use the MPLS in the segment routing as well. That's a advanced level of the syllabus in the service provider. In your CCI enterprise, you only have a MPLS Unicast and MPLS layer 3 VPN in a CCI service, CCI enterprise. In a CCI service provider, you have a lots of flavor of the MPLS, almost 50 hours of the session only on the MPLS part. Now, so that's how you can check which interface is enabled in the MPLS or I guess the LDP protocol. And even if you check on the R3, if you see the R3 configuration, did I mention the any LDP protocol? No. But if you check the command, it will show you, hey, it's LDP. Now you can check the neighbor on data 1. You can see the neighbor of the R2. So MPLS LDP neighbor. My LDP neighbor is a 2.2.2. R1 is seeing that. And local identifier is what? 101. This is the TCP connection we have. The port number 646. And if you check the L5 table, so MPLS porting table, that's called as L5 table. It will show you the L5 table. For each route, you can see that I have labels over there. Local label and outgoing label. Local label, which is assigned by the router 1 itself. Outgoing label means what? Which is router 2 has shared the label information to the router 1. Local means what? Own label, which I assign to the each router. So router 1 has assigned the 2.0 as a 16, 3.0 as a 17, 4.0 as a 18, 5.0 as a 19, 6.0 as a 20, 7.0 as a 21. This label 17, 18, 19 for this route, I have received from the router 2. So now you can send the packet from R6. All done. And so if you see, my router is doing the label lookup. So you can see the label 21, 21, 21 only comes in the picture. So if you see the from the router 6, I send the packet from 6.6.6, 7.7.7.7, right? Source and destination. When this IPv4 packet is received on the router 1 interface, right? Router 1 is gonna perform which lookup? Routing tail lookup or IP SEP table lookup. So on this particular interface, there is no MPLS, so it will look up the SEP table. So IP SEP, and if you put the command 7.7.7.7 detail, it will show you that, hey, you know one thing, you need to go with the level 21. So what he will do that? He will do the push operation. Push means what? The push means what? He will insert the label. Push operation means what? He will insert the label. That's the meaning of push. Push means pushing the label. So he will insert the label 21. On which header? This is the header. Now, what happened? If you check the show MPLS forwarding table again back, so 7.0.0.0. So 21 is the outgoing label. So router 1 will send this packet to the router 2, right? Via 1/0 to router 2. When the router 2 will receive the packet, what router 2 will do that? Same way. So MPLS forwarding table. So the router 2 will receive the packet with the label 21. So when I receive the packet 7.0.0 with the label 21, I will replace with the 21 again. I will do the swap operation. When the R3 will receive the packet with the label 21, what it will do that? It will again send the packet to the 1/0 to the 34.04 by the same label 21. So again, it will do the swap operation and it will send the packet to the home R4. When R4 will receive this packet, it will again do the swap operation. So if you remember that I told you that the label could be duplicate, and it's happening because label are local to the router. So on the local router, it will be unique. And is that all unique? But router by router, it could be duplicate. And when the router 5 will receive this information, local level is 21, outgoing level is what? No label. Why? Because on the outgoing interface, there is no MPLS enable. So it will do the pop operation. It will remove the label 21 and it will just send the normal IPv4 packet. So from here, I send the IPv4 packet, and from here, I will receive the IPv4 packet. So customer has no idea that MPLS has been enabled on the service provider side. They will receive the normal IPv4 packet. They have sent the normal IPv4 packet. So in the complete service provider, will do the push operation is inserting the label. Swap operation is replacing the label with another label. Pop means what? Remove the label and send the normal packet. That's how the three operation we are doing that in our normal MPLS. That's your MPLS, guys. Again, it's not done. We have a lots of thing in the like track by track, man. Not the everything is there in the enterprise